Welcome to Spaceverse, your portal to cosmic adventures. Is Betelgeuse's demise near? It's undeniable that the enormous star will eventually depart the cosmic scene with a dramatic explosion. However, some researchers suggest this event might happen sooner than we previously believed. What does this mean for us? Could the immense supernova also throw Earth into turmoil? And why is Orion's shoulder star currently displaying behavior that confounds astronomers? Bigger, the Sun. In our daily perspective, the Sun often represents the ultimate cosmic benchmark, unmatched by any other celestial body. In this context, it is entirely accurate. With a diameter of at least 1.4 million kilometers, the Sun vastly overshadows all of its planetary companions. Theoretically, the Earth could fit inside the Sun over 1.3 million times. However, in comparison to other galactic giants, our central star is shrinking more and more. Located in the constellation Orion, Betelgeuse surpasses our Sun in every conceivable astronomical measure. Specifically, the giant star, known worldwide as Betelgeuse, has a diameter 800 times greater than that of the Sun. In this constellation, the Sun appears as a tiny pinhead that could fit into Betelgeuse 500,000 times. The differences in luminosity are equally striking. Betelgeuse shines 10,000 times brighter than our Sun. Consequently, it's possible to see this celestial body approximately 650 light-years away from Earth with the naked eye in the night sky. In the northern hemisphere during winter, spotting the red supergiant is nearly impossible to miss, and this has been true for a long time. Betelgeuse was even noted 2,000 years ago as a yellow-orange dot in the sky. However, like all other celestial objects, Betelgeuse is not a static, unchanging star. On the contrary, its radius, as determined by interferometry, fluctuates by about 15%. Notably, Betelgeuse's radius was the first to be measured using this technique. These fluctuations are not limited to the radius, they also impact its brightness. Consequently, Betelgeuse experiences a noticeable change in luminosity approximately every 270 days, a phenomenon linked to its advanced stage of development. In principle, red supergiants are known for their characteristic pulsation, which involves expanding and contracting over time. This pulsation is closely linked to fluctuations in brightness, creating a dynamic and variable appearance. However, a few years ago, experts were confronted with an extraordinary and puzzling example of this phenomenon that revealed just how dramatic and complex such variations can be. An inexplicable interplay. In October 2019, Betelgeuse began a process that led to an unprecedented and extreme reduction in its luminosity. By February 2020, the star's brightness had plummeted to less than 40% of its average initial value. This marked an unprecedented level of dimness for Betelgeuse, a star that had always been a prominent and bright feature in the night sky. Since the inception of astronomical studies, Betelgeuse had never been observed to fade so dramatically. Upon discovering this significant change, astronomers and astrophysicists immediately began investigating the underlying causes. Some researchers proposed that the sudden drop in luminosity could be attributed to the star's inherent brightness cycles. These cycles involve periodic changes in brightness due to the star's pulsation and other dynamic processes. They suggested that the observed dimming could be a result of several overlapping brightness cycles interacting in complex ways. However, other experts expressed concern that the drastic dimming might be indicative of a more catastrophic event. They speculated that the sudden and severe reduction in brightness could signal an impending supernova, a stellar explosion of immense scale. The possibility of such a dramatic event raised significant alarm and interest within the scientific community, prompting further investigation and analysis. The drastic and unexpected decrease in Betelgeuse's luminosity has led to a deeper examination of the star's behavior and its future. Understanding whether this dimming is part of a regular cycle or a precursor to a supernova remains a crucial question for astronomers. This ongoing investigation into Betelgeuse's luminosity fluctuations continues to captivate the scientific community and underscores the complexities of studying such dynamic and colossal celestial objects. In general, a stellar explosion is preceded by the star expanding significantly and undergoing a notable decrease in brightness. However, since no star has been observed directly before a supernova, it's unclear whether this dimming occurs several years or just hours prior to the event. Nonetheless, it is certain that Betelgeuse will eventually erupt in a spectacular supernova. Based on current knowledge, the red supergiant is expected to leave the cosmic stage far in the future, as it has only recently entered its final phase. The supernova is anticipated to occur approximately 1.5 million years from now. Some researchers, however, predict a shorter time frame, estimating that Betelgeuse could vanish from the sky maps within the next 100,000 years. After Betelgeuse regained its former brilliance in April 2020, scientists were able to uncover the reason behind the drastic drop in brightness that had puzzled them. By August of the same year, observations from the Hubble Space Telescope revealed that the star had ejected a massive cloud of hot, dense material. This material eventually cooled and condensed into dust, which then blocked and obscured the light emitted by the star. From our vantage point on Earth, this cosmic dust veil created the illusion that Betelgeuse had dramatically lost its luminosity. With this explanation for the previous dimming finally identified, scientists were hopeful that the mystery had been resolved. However, it wasn't long before Betelgeuse introduced a new puzzle. Since the beginning of 2023, the star has been shining with much greater intensity than usual, raising new questions and sparking further investigation into its behavior and the underlying causes of these dramatic changes in brightness. What will happen when Betelgeuse explodes? Whether Betelgeuse explodes soon or in many millennia, one certainty remains. Its transformation into a supernova will dramatically reveal the powerful forces at work in the universe. Currently, Betelgeuse shines 10,000 times brighter than the Sun, but researchers predict that its supernova explosion will result in a staggering 16,000-fold increase in brightness. Some scientists speculate that the supernova could shine with the intensity of a crescent moon in the night sky, while others believe it might match the brightness of a full moon. Regardless, the supernova will be a spectacular event visible from Earth. The pressing question is what impact this monumental event will have on our planet. Could Earth and its inhabitants be at risk of being destroyed by this cosmic phenomenon? Fortunately, the situation is not as dire as it might initially seem. The primary concern with such stellar explosions is that the accompanying gamma-ray burst could potentially impact Earth. However, in the case of Betelgeuse, experts have reassured us that this will not be a problem. Since the star's axis of rotation does not align with our planet, the gamma-ray burst from the explosion is expected to be too weak to cause any harm to Earth. What adds to the intrigue is the possibility of witnessing two separate flashes. Following the explosion of Betelgeuse's core, the expelled material might collide with the surrounding static shell of the red supergiant. This secondary collision could produce an additional burst that would also be visible from our planet. But what will remain after this dramatic event? Will Betelgeuse's former location be marked by a vast emptiness? Most likely, it will not. Typically, a supernova of this magnitude leads to the formation of a neutron star, a dense remnant with about 20 times the mass of the Sun. Is Betelgeuse spinning too fast? Neutron stars are renowned for their incredible rotational speeds, with some spinning at astonishing rates. For instance, in 2004, astronomers discovered a neutron star that completes 716 rotations per second. While Betelgeuse is far from reaching such extreme speeds, its rotation is already raising eyebrows among scientists. Recent observations from the ALMA radio telescope in Chile reveal that Betelgeuse appears to be spinning unusually fast. Its rotation speed, exceeding 5 kilometers per second, is about 50 times faster than what would be expected for a red supergiant. Typically, stars slow down as they expand, and Betelgeuse is currently the only known red supergiant with such rapid rotation. So, what could be causing this anomaly? One intriguing possibility is that Betelgeuse might have swallowed another star. This scenario suggests that Betelgeuse could have consumed a smaller companion star during its evolution. While this idea might seem outlandish, it's not uncommon for massive stars to interact with nearby stellar companions. If this stellar consumption occurred, it could have transferred the angular momentum of the absorbed star to Betelgeuse's outer layers, resulting in its accelerated rotation. Is Betelgeuse spinning too fast? Jingzi Ma from the Max Planck Institute for Astrophysics in Garching near Munich offers a different perspective on the rapid rotation of Betelgeuse. According to Ma, the star's surface is dominated by enormous convection currents, massive bubbles of rising and falling plasma that could be skewing our understanding of Betelgeuse's rotation speed. Researchers have derived the star's rotational speed by analyzing its bipolar surface structure. This analysis has shown that one half of Betelgeuse's visible surface exhibits a blue shift, while the other half shows a red shift. with variations of several kilometers per second. This shift could be attributed to the movement of convection currents rather than the star itself spinning at high speeds. Large convection bubbles, or groups of these bubbles moving towards and away from the observer, could create a bipolar velocity field, making a non-rotating star appear to spin rapidly around its axis. This hypothesis suggests that the observed rapid rotation could be an optical illusion caused by the dynamic nature of Betelgeuse's outer layers. The interactions between these convection currents and the star's light might be responsible for the apparent speed, rather than an actual increase in rotational velocity. Future studies will be crucial to confirm or refute this theory. Scientists are eagerly awaiting more high-resolution images from the ALMA Observatory to provide clearer insights into Betelgeuse's rotation. Initial observations have already been conducted, but the data is still being analyzed. And that's it. Thanks for tuning in to Spaceverse. We've journeyed through the mysteries of Betelgeuse, from its potential explosive fate to the enigmatic clues behind its rapid rotation. Whether it's the spectacle of a future supernova or the intriguing dynamics of stellar convection, we've covered some truly cosmic ground. Don't forget to like, subscribe, and hit the bell icon to stay updated with all our space explorations. Until next time, keep looking up and stay curious.